Hi guys, this is AS Chemistry, Organic Chemistry, and we are doing carbonyl compounds. Question 1. The reaction of hydrogen cyanide with propanone is an important first step in many organic syntheses. Give the full name of the mechanism of this reaction. So propanone is a ketone, and ketone when it reacts with hydrogen cyanide undergoes nucleophilic addition. Complete the diagram to show the mechanism of the reaction of hydrogen cyanide with propanone. Draw the structure of the intermediate and the product of the reaction. Include all relevant charges, partial charges, curly arrows, and lone pairs. So here we have propanone reacting with the CN negative ion of HCN. So first we will include the partial positive and the partial negative charges on the carbonyl carbon and the attached oxygen. And then we include the lone pair of electrons on the carbon atom of the Cn negative ion. Then we have a curly arrow going from this lone pair towards the partial positive charge on the carbonyl carbon, because of which the carbon oxygen pi bond undergoes heterolytic fission and breaks. This results in formation of an intermediate in which we have a carbon atom attached to two CH3 groups. This is from propanone. The C double bond O is now converted into C single bond O with a negative charge on it, because now there is a lone pair of electrons on the oxygen atom, because the pi bond that broke, the both the electrons involved in the bond formation are retained by the oxygen atom now, and we have a bond formation between the C triple bond N group and the carbonyl carbon. Now we have the H positive ion from HCN available for this reaction, and an arrow, a curly arrow going from the lone pair of electrons on oxygen towards a positively charged H positive ion. The H positive ion adds on to the oxygen atom, turning it into an OH group attached to the carbon, which was carbonyl, which is attached to two separate CH3 groups and a CN group, forming a cyanohydrin or a hydroxynitrile. So this is how the nucleophilic addition reaction proceeds when propanone reacts with HCN. Question 2. Some reactions of compound PC5H8O are shown. So P, when it is reacting with hydrogen gas and nickel catalyst, forms compound Q. When it is reacting with NaBH4, which is a mild reducing agent, it forms compound R. When it is reacting with cold acidified KMnO4, it is forming compound S. And when it is reacting with alkali and iodine, it is forming compound T plus a compound which contains a double bond and a carboxylic group. So now we need to put down the structures of these compounds Q, R, S, and T. So compound Q is formed by reduction or hydrogenation of compound P. So in compound P, we have a double bond present, which is an alkene group. So the hydrogen gas that is reacted with compound P will add on to the double bond and convert it into a single bond. So we have got the same compound, but instead of a double bond for alkene, we will have a single bond, because both the carbon atoms that were involved in double bond formation now have a hydrogen added on to them. And the double bond O group will stay as it is, which is the ketone group. Next, we have R, in which we've got compound P undergoing reduction in the presence of a mild reducing agent, which is NaBH4, which will reduce the ketone into a secondary alcohol. So we have the same structure with the double bond present, but instead of double bond O, now we will have single bond OH present, as the ketone group will be reduced to a secondary alcohol. For structure S, we have cold acidified KMnO4 reacting. cold acidified KMnO4 is responsible for the double bond being converted into a single bond for alkene and each carbon atom now having an OH group attached to it. So we have the same structure formed. The double bond of ketone stays as it is, but the double bond of alkene now has a single bond OH group present on both the carbon atoms involved in the double bond formation. And as for compound T, this reaction is the reaction with aqueous alkaline iodine. So the product formed, which is displayed in its chemical formula, has a single bond O negative, which will be attached to Na positive. This will be the sodium salt of carboxylic acid, and the other product formed would be CHI3. So this would be in its chemical form written as 3 iodine attached to a carbon, and the hydrogen will not be shown because this is the skeletal formula. So this is CHI3, which is triiodimethane or iodoform. So these are the four products formed on different reactions of compound P. Give the systematic name of compound P. So compound P is a ketone with a double bond present. This is compound P. So the naming would start by giving the least number to the ketone group. So 1, 2, 3, 4, and 5. So the parent compound is pentane, and the name of the compound would be, since it is having 5 carbon atoms, so it would be pent 3ene, because we have the double bond present between the third and the fourth carbon atom, and 2-one because the ketone group is on the second carbon atom, and the preference would be given to the ketone group over the alkene group. So this compound is called pent 3-ene 2-one. What would you observe when compound P is reacted with 2,4-dinitrophenyl hydrazine or 2,4-DNPH? So 2,4-DNPH is a test for the presence of a carbonyl group. So we do have a carbonyl group present here. So what we would observe would be a yellow or orange. So we can write it as yellow orange precipitate. So this would confirm the presence of a carbonyl group in the compound pent 3-ene 2-one. Question 3. 7 reaction types are listed: addition, substitution, oxidation, elimination, hydrolysis, condensation, and reduction. Name the type of reaction involved when Tollens reagent is used to identify an aldehyde. So when Tollens reagent is used to identify an aldehyde, the aldehyde is oxidized into a carboxylic acid salt. So oxidation occurs with respect to the aldehyde. However, the silver ions present are reduced to silver metal. So if we talk about the reaction with respect to the silver ions, they undergo reduction. So depending on what we are referring to, we will write either oxidation or reduction. But here in the question, it says aldehyde. So with respect to aldehyde, the reaction is called oxidation because the aldehyde present is oxidized. Name the type of reaction involved in the test for a carbonyl group using 2,4-DNPH. So 2,4-DNPH, when reacted with a carbonyl compound, undergoes a condensation reaction with it because the 2,4-DNPH molecule reacts with the carbonyl compound and a water molecule is given off. So this reaction is called condensation. Name the type of reaction involved in the reaction of a ketone with NaBH4. NaBH4 is a reducing agent. So a ketone undergoes reduction to form a secondary alcohol. So the type of reaction is reduction. Name the type of reaction involved in the reaction of an aldehyde with HCN. So an aldehyde reacting with an HCN is an example of a nucleophilic addition reaction. So we would write nucleophilic addition. However, since the list does not mention nucleophilic, so and only addition is present, so we would write this as addition only, because we need to follow whatever is given, but we also must remember that the type of addition that is taking place is nucleophilic addition. Question 4. The isomers F and G, C5H10O, both form an orange precipitate when reacted with 2,4-DNPH. F is unbranched and reacts with alkaline aqueous iodine to produce a yellow precipitate. So this has a methyl ketone group present. So it's a ketone and it is unbranched. G does not react with alkaline aqueous iodine, so it does not have a methyl ketone group present. It contains a chiral center and produces a silver mirror when warmed with Tollens reagent. So this is an aldehyde. Name the yellow precipitate produced by the reaction between F and alkaline aqueous iodine. So that precipitate is called triiodomethane, which has a structure of CHI3, and it is also known as iodoform. Give the structural formula of F and G. F is CH3CO, and since we've got 5 carbon atoms, so we continue the chain CH2, CH2, and CH3. And G is an aldehyde with a chiral center and 5 carbon atoms. So if we are to make a chiral center, so we can have a carbon atom with a CHO group on one end, a hydrogen on one end, a CH3 on one end, and we're left with 2 carbon atoms, so a CH2 and a CH3 on the fourth position. So that makes this carbon atom chiral. So writing this formula in its condensed form would be CH3, CH2, CH. We have CH3 attached to the CH and then CHO. So this is the compound G, which satisfies all the requirements given in the question. Explain the meaning of the term chiral center. So a chiral center is a carbon atom that forms 4 single bonds with 4 different atoms or group of atoms. Question 5. W is CH3, CO, CH2, CH3. So this is butane 2-one. The reaction between W and alkaline aqueous iodine produces a yellow precipitate. Give the name of the compound formed as a yellow precipitate in this reaction. So the name of the compound is triiodomethane. Its formula is CHI3, and it is also known as iodoform. Give the name of W. So it is butane 2-one. There are 2 structural isomers of W that are also carbonyl compounds. Draw the structures of these 2 isomers of W. So it is supposed to be a carbonyl compound and it is an isomer. So one of the isomers of butane 2-one would be butanol, because a ketone and an aldehyde are functional isomers of each other, which are structural isomers. So we would have CH3, CH2, CH2, and CHO. So this would be butanol. And another isomer of W could be another aldehyde, but one of the carbon atoms becomes a substitute group. So we have three carbon atoms in the straight chain and one of the carbon atoms acting as a methyl group forming a branched aldehyde. So the name of this aldehyde would be 2-methyl propanal, 2-methyl propanal. So this is also another structural isomer of butane 2-one. Two reactions of W are shown. So W, when it undergoes reaction 1, produces a secondary alcohol. So reaction 1 is basically reduction of W. And in reaction 2, W forms a compound with an OH group and a CN group attached to the same carbon atom. So this compound is called a hydroxynitrile or a cyanohydrin. That means reaction 2 is a nucleophilic addition reaction. Identify the type of reaction occurring in reaction 1. So this is reduction. Identify the reagent for reaction 1. So if we need to reduce a ketone into a secondary alcohol, there are two possibilities. Either we use LiAlH4 plus triether, which is a harsh reducing agent, or we can use a milder reducing agent, which would be NaBH4 plus water. Reaction 2 is carried out by adding a mixture of HCN and NaCN to W. The product X is formed as a mixture of two isomers. Complete the mechanism for this reaction, include the structure of the intermediate form and all necessary charges, dipoles, lone pairs, and curly arrows. So in this case, we've got a partial positive charge on the carbonyl carbon atom and a partial negative charge on the oxygen atom that forms a double bond with it. And we have a lone pair of electrons present on the carbon atom in CN. So this lone pair of electrons gets attracted towards a positively charged carbonyl carbon, because of which the pi bond between carbon and oxygen undergoes heterolytic fission and breaks. This results in the formation of an intermediate in which we've got a carbon atom attached to an oxygen atom having a negative charge now and a lone pair of electrons on it. On the other hand, it has a CH3 group which was there in the main parent compound. It has a CH2 and a CH3 group which was also there in the parent compound, and it has attachment of a CN group, which is the bond that was formed when the CN negative ion attacked the carbonyl carbon. And now in the same reaction, we have got H positive ions present. The lone pair of electrons on the oxygen atom will be attracted towards the H positive ion, and the H positive ion will be added onto the oxygen atom, converting the O negative ion into an OH group. And with this, we have formation of the cyanohydrin, which is compound X. And our question says that it forms two isomers, and we can see that the carbon atom to which the OH and the CN group are attached has four different groups attached to it, so making it a chiral carbon atom. State the name of the type of isomerism shown by X. So X shows optical isomerism. Explain fully why X shows this type of isomerism. X has a chiral center which is a carbon atom forming four single bonds with four different atoms or group of atoms. This makes the compound asymmetric and thus it has two non-superimposable mirror images present, which are the optical isomers. So optical isomers are non-superimposable mirror images of each other. So if it has two non-superimposable mirror, two structures, which are two structures which are non-superimposable mirror images of each other. So this is the explanation of why compound X shows optical isomerism. If X is treated with ammonia and the product hydrolyzed, a compound Y is obtained that contains 51.3% carbon, 9.40% hydrogen, 12.0% nitrogen, and 27.3% oxygen by mass. Show that the empirical formula of Y is C5H11NO2. So what we need to do is we need to put down the four elements present, C, H, O, and N, and then we need to calculate its empirical formula. And in order to do that, we would have the percentages of each element: 51.3 for carbon, 9.4 for hydrogen, 27.3 for oxygen, and 12 for nitrogen, divided by their AR values. So the AR of carbon is 12, for hydrogen is 1, for oxygen is 16, and for nitrogen is 14. This would give us a ratio of carbon as 4.28. For hydrogen, it would be 9.4. For oxygen, it would be 1.71. And for nitrogen, it would be 0.857. The next step we need to do is divide each of these by the smallest value among them, which is 0.857. So we divide each value by 0.857, which would give us a ratio of each element as 5 for carbon, 11 for hydrogen, 2 for oxygen, and 1 for nitrogen. So we end up with C5H11, then we write N, and then we've got O2, which is the same empirical formula as required in the question to be predicted. The empirical formula of Y is C5H11NO2 and the MR of Y is 117. Deduce the molecular formula of Y. You must explain your reasoning. So what we need to do is first we need to calculate the empirical formula mass, which will be equal to 12 into 5 plus 1 into 11 plus 14 into 1 plus 16 into 2. So this gives us a value of 117. So if the empirical formula mass is equal to MR of the compound, this means that the empirical formula is equal to the molecular formula of the compound. So the molecular formula here would be C5H11NO2, and we need to explain, since the empirical formula mass is equal to the molecular formula mass. The empirical formula is equal to the molecular formula of the compound. And this is the explanation of why the empirical formula C5H11NO2 is also the molecular formula of Y, which is C5H11NO2. Question 6. P, Q, and R all contain 5 carbon atoms. So P is a cyanohydrin, Q is a ketone, and R is an aldehyde and an alkene. A student carries out several tests to distinguish between P, Q, and R. Complete the table identifying any observation for the reaction of each reagent with P, Q, and R. If no reaction occurs, write no reaction. So compound P, when it reacts with sodium metal, we have production of hydrogen gas. So observation would be effervescence. With compound Q, we do not have any OH group present, so there would be no reaction for compound Q. And for compound R, we've got an aldehyde group and an alkene group, none of which would react with sodium metal. So we would have no reaction for compound R with sodium metal as well. Next, with compound P, 2,4-DNPH does not react because compound P does not have any carbonyl carbon present, whereas Q has a ketone group present. So with 2,4-DNPH, we have the formation of a yellow orange precipitate. And with respect to compound R, an aldehyde group is present. An aldehyde group is also a carbonyl group. So R will also give a positive result, which is the formation of a yellow orange precipitate. Next, we have reaction with acidified K2Cr2O7, which is an oxidizing agent. So the OH group present in P is a tertiary alcohol, and tertiary alcohols do not undergo oxidation. So no reaction is already written. With Q, we've got a ketone. A ketone cannot undergo further oxidation with acidified K2Cr2O7. So we would write no reaction. For compound R, an aldehyde group is present. So an aldehyde is oxidized to a carboxylic group or carboxylic acid group. So the color change observed would be color changes from orange to green. So the color of acidified K2Cr2O7 turns green when we add it to compound R, as the aldehyde group is oxidized to the carboxylic group. Q is reduced to NaBH4. Write an equation for the reaction of Q with NaBH4. In your answer, use square brackets H to represent NaBH4. So the molecular formula of Q is C5H10O. We need to remember that Q is an aldehyde. So the CHO group will be reduced to CH2OH group. So we have addition of two hydrogen atoms into the compound. So that would be 2 square brackets H, because this represents the two hydrogen that is being added. And since two hydrogen are being added, the product would be C5H12. That is 10 plus 2 is 12 and O. So this is the equation for the reduction of compound Q with NaBH4. R exists as a pair of stereoisomers. Identify the type of stereoisomerism shown by R and draw the structure of the other stereoisomer. So we need to revisit the structure of R to understand what kind of isomerism it shows and what would be the other stereoisomer for R. So here we can see that R is an alkene and it has got two carbon atoms with a double bond between them, each having a hydrogen atom on it placed on opposite sides of the double bond. So this is representing a trans isomer for compound R. Therefore, the type of isomerism that this compound shows is cis-trans isomerism or geometrical isomerism. And the other isomer that we need to draw would be both the hydrogen atoms would be on the same side of the double bond, which would be the cis isomer. So the type of isomerism is geometrical. We can also write that it is cis trans. And the other stereoisomer would be the two carbon atoms with the hydrogen atoms on the same side of the double bond and the aldehyde group CHO and the alkyl groups CH2, CH3 on the same side of the double bond as well. So this is the cis isomer of compound R.